Good morning to all. Myself, Dr. Arun Negamia from Aerospace Engineering Department. Today, I am going to take one topic from CFD for aerospace applications. So, I am going to take one topic for finite element techniques. So, in that finite element techniques, where the finite element techniques it will be utilized for the day-to-day life and main applications of these cases. So first one is we are going to see that how can the finite element method help the design engineer. So for example, already I told you, so unstructural cases, it will be solved by using this method. So irregular shape and complex shapes, it can be analyzed by using this finite element method. So in that finite element method, it will be utilized for the steady state and time dependent process and a linear and non-linear problems, and either it can be utilized for the many applications like solid mechanics, fluid mechanics, chemical reactions, electromagnetics, biomechanics, heat transfer, and many applications it will be using for this finite element methods. And in that finite element methods, the main usage, first one is material wastage, and the second one is we can reduce the uh, time for the fabrication process, and optimizing the process parameter of materials, and we will find out the where the failure it will be happen during this uh, analysis, predicted analysis we can done by using this method. And next one is the basic steps involved in FEA. So in that many basic steps are involved in. First one is the discretization. So in that discretization, the many survey it will be taken in that discretization. So here the in this survey the continuous problem domains is divided into mesh that is called as a discretization. So in the discretization, the large area it will be cut out into smaller area. So in that smaller area we can uh, analyze it very easily. Next one is approximation functions, element stiffness matrix, total stiffness matrix. So these are all the things. Well, it will involve in that steps. And phases, it can be classified into three phases: pre-processing, solution, and post-processing. So in that pre-processing, so in that geometry, it can be cutted into subdomain. So in that each subdomains, it will be involved for this analysis. So in that analysis, some mathematical problems and some mathematical properties it will be applied for this area. Next one is the solution. So by applying the governing matrix equations, by applying the many structural problems solutions, finally we will get the one good value and good solutions from this survey. Post processing, after getting the solutions, we will check the uh, uh, analysis for this survey. So for example, stress and where the failure it will occur, these are all things it will be taken for this survey. Next one is the advantage of FEA. So in that advantages of FEA, so complex materials can be analyzed by this method, and easy to handle the vibration and heat transfer materials, and easy to handle the loaded materials like point load, uniform distribution load, uniformly varying load methods, and the time dependent process. So here we can take in some cases that it will take the more than hour for this survey, and it will be taken for the some temperature dependent properties like creeping, swallowing, these are all things it will be taken by using these problems. Next one is the drawbacks. So in that drawbacks, some numerical results, it will be taken the more times compared to the normal time. So in that cases that we need more high configuration computers and high configuration softwares. It will be used for this FEA software. So in that, for example, here we need more than 8 GB RAM and 2 GB graphics card and 240 GB hard disk. In that cases, it will be required for this FEA software. And here it will take and it will consume the more RAM area during the software running time. Next one is these are all the software packages we nowadays we are using this study. First one is ANSYS, Nastran, Python, NISA, LSDNA, Hypermesh, CATIA, SolidWorks, and Cosmos. So in educational industries, they are using the SolidWorks, CATIA, and ANSYS for this finite element analysis. So thank you. We will catch you on next topic on next series.